Morning, dear students. Hope you are doing good. And today we are going to discuss the concept that is related to distribution system. Here, water we are discussing about water distribution system. We are in the 6th unit. Previously, we have seen the different methods related to water supply, methods of water supply, followed by we have seen the layouts of distribution system. We have seen layouts of distribution system, where we have seen 4 types. We have seen 4 types of layouts. Dear students, hope you are well content in all these sessions and you learn many concepts with respect to this water supply, right from the source to the consumer, else to the public. Dear students, we learned and we discussed lot of topics which we used to encounter in our daily life regularly. As most of you are staying in the cities and towns, you may be observed and you may be noticed many times about this water supply. And now you understood how the water is storing and how the water is being collected. That means by intakes, and how we can estimate the demand, estimation of water demand we have seen in the first unit itself. How we can estimate the population, also we have seen. That means once if you are thorough all these topics, I am sure that you are very much content with this municipal water supply. Of course, water supply engineering. Dear students, and you learned a lot about the sedimentation, coagulation, and the filtration also. And one more time, for your better understanding and for your better exercise, not understanding, I have given as an assignment all those 4 or 5 very much important topics. The sedimentation design is mandatory for you. You must know how to design sedimentation tanks. We have seen. And you must know how the large quantity of water is being treated regularly. That means slow sand filters and rapid sand filters. Fluoridation, you may be here and there. The word is so familiar about these fluorine problems in the water. And followed by, you have seen the chlorination used to observe everywhere almost. In the most of the cities and towns, sometimes we used to sense the chlorine composition in the water sometimes. That is also as I have given as an assignment. And I just given in the 6th unit also layouts of distribution system. You must know what distribution and which system is adopted at your locality, which type of system has been adopted for water supply. You must know. So as in a practicing method, as to practice, I given all these important in the sense all these topics as an assignment. You please go through all the concepts, and these are very much important to you. And somewhere other way, at one point, you may encounter these type of questions. Once you completed your engineering, you may encounter all these type of questions. Where the water will be treated and how we can estimate the population, and what are all the precautions that you must take while constructing these intakes, while constructing this overhead tanks, reservoirs, you must know. So every topic we discussed more elaborately with much focused content. And try to rewind these videos if you want any time to just get back the information. You can understand what is the concept behind that so and so technology. In the second unit, second in the sense in the second part, exclusively, we are dealing with treatment. First two units, fourth unit and fifth unit, linked with treatment only. That means the first unit is source, second unit is collection. Of course, as intakes are there, third pipelines also we discussed there itself. Third unit speaks about quality and various regulations and various characteristics, features of water and WHO standards we discussed. Fourth unit and fifth unit is about the treatment. Now we are distributing water to the public. Now we are distributing the water to the public, and what are all the precautions and what are all the concepts you must know. They are discussing, all those topics are discussing now in this unit. We have seen the types of supply, that means methods of supply. We have seen layouts of distribution system, and we already seen the other associated topics like valves. Whenever the water is being supplied, there must be good set of valves for better and efficient maintenance of water flow. And in this distribution system only, there is a topic joints, which we already discussed in the second unit. Pipes and joints. Different types of joints you must learn, and you must focus on the diagrams. Everywhere the diagram is speaking to us. See here, slide share. One moment. Just hold one moment. See here, almost everywhere we are discussing various concepts. Almost in all the units, what we discussed, if we have a look, we were able to understand different types of concepts related to water supply engineering. See, what I am speaking is here, try to focus on all the concepts by listening, one or more times, on your convenient times to get back the information. What we have seen and what we have discussed. See here in the topics joints, actually it is very easy topic when you understand the concept, or as when you understand, or as when you are well content of these diagrams. Why I'm going back means here joints. It's a very important topic in distribution system, joints and walls. It is in second unit as well as in the sixth unit also there. Joints, you must learn how to draw these diagrams. Even though you wrote everything, unless the diagram is not drawn by you, all your efforts goes to waste. So you must learn about these basic concepts. What are all the characteristic features you must know at the time of adopting, at the time of selecting joints. Likewise, even after joints, you must focus in distribution system valves also. What we have seen in the previous class, various valves, various types of valves, sluice valves or gate valve, check valve or reflex valve, air relief valve, and spar valves. You know the concepts, and you understood what type of pipeline is, you know the lifespan of different pipelines, and you know the types of joints, and you are aware valves also. Now we are going to discuss one method, that is Hardy-Crass method. This is very easy. Nothing is there. We are just substituting the formula. That's it. You must remember the points as in a concept. In this method, the corrections are applied in each successive trial. The head loss in each pipe is determined by pipe flow formula. We are just Hardy-Crass and equivalent pipe methods. This is one of the pipe method. The corrections are made the flow in each pipe until the heads are balanced. And the principle of connectivity is satisfied in each junction. Now, QA here, have a look. QA is assumed flow and QE is the actual flow. This is Hardy-Crass method we are discussing. QA is assumed flow and QE is the actual flow, and it can write as QAE, equal to Q, and where Q is delta plus QA. Now, have a look focusedly. There is an interconnected point to point. Now, the head loss in the pipe under reference is HL, and it is determined by the formula HL equal Q into QA, K into QA, where K is constant and depends on size of the pipe, and also determined by Hazen-Williams formula, which states HL equal K into Q power 1.85. What is this 1.85? Note, according to Hazen-Williams formula, X equal is 1.85. Now you are clear up to here. Delta EQA equal to approximately Q, and Q equal to delta plus QA, where QA is assumed flow and Q is the actual flow. See here, now the head loss in the pipe under reference is HL, and it is determined by the formula HL equal K into QA, where K is constant and depends on size of the pipe, and also determined by the Hazen-Williams formula, which states HL equal K into Q power 1.85. This 1.85 means X equal to 1.85. That means why I am speaking about this X, here will come. HL equal K into, what is Q here? What is Q here? Q is delta plus QA. What is Q? Q is delta plus QA. So K into delta plus QA power X. Actually, this 1.85 is equal to, and instead of 1.85, we put it X. Now we are just transforming equation equal K QAX plus XQA X minus 1 into delta. We are just converting the equation. Hope you know all these integrations. For closed pipe system, the head loss is 0 and can be written as, or as write as sigma K equal to QA power X plus XQA X minus 1 into delta equal 0. What is the statement here? For closed pipe system, you know how it comes? Hope you know how it comes, no? So we are just differentiating this, we are just elaborating this equation. That's it, nothing else. So for closed pipe system, the head loss is 0 and can be write as sigma K. So for closed pipe, head loss is 0. So total is QAX plus XQA X minus 1 delta equal 0. Or we can write it as simply we are just taking off the equation from this K QA power X equal minus sigma K QX minus 1 into X into delta. Same, we are just taking this into this side, and equation is like this. Followed by, for closed pipe system, delta is negligible. It can take out from the system, where we can convert it as sigma K A power X equal simply, we are just delta is taking out. Earlier the delta is here, now we are taking off from the system. So sigma delta equal QA power X minus 1 into X. So as we are taking off delta equal minus sigma KA power KQA power X into by sigma delta. Simply again we are writing this equation. So delta equal sigma HL by QA. Simply we are just substituting. Simply we are substituting and elaborating the equation. That's it, nothing else. What you should remember? Or in each or method, corrections are applied in each successive trial. Head loss in each pipe is determined by flow formula. See here, all the corrections made flow in each pipe until the head loss balance, until the heads are balanced. Assumed QA is assumed flow and Q is the actual flow. Q equal to delta plus QA. You must remember. See here, HL, now the head loss in the pipe with reference, under reference is HL. And it is determined in the formula. How can you find out, determine the HL? Is this formula. See here, where K is constant, it depends on size of the pipe, and also determine Hazen-Williams formula, which states HL equal to, which states again, Hazen-Williams also states HL equal K into Q power 1.85. And the same equation we are writing here, instead of 1.85, we are substituting X. From where it comes? Simply in the previous step, Q equal to delta plus QA. And we are just re-elaborating the equation to solve the equation. For closed pipe system, the head loss is 0 and can be write as, simply we are taking sigma K equal to, we are just dividing plus QX minus 1 into delta equal 0. Or we can write this as simply sigma K into QA power X equal to minus, and it comes, okay, sigma QX power minus delta, and X we kept here, there it's somewhere. And then for closed pipe system, delta is negligible. It can taken out from the system. Once we are taken off this delta, and the equation will be like this, where delta is minus sigma K into QA power X by sigma delta K into Ka X power X minus 1 into X. And ultimately, this is the equation for Hardy-Crass method. Hope you understood. If you have any doubts, please contact me in the domain, either phone, message, or mail. Thank you.